All right, guys, Greaves back. All right, we're going to take a look at a different type of circuit than last time. Last time we looked at the series circuit, right? So let's kind of recall a little bit. Series circuit, only one, right? One path for current to flow. So today we're going to look at something called parallel circuits, right? So what's the difference? Well, it's a little bit simple, right? It's if a series circuit is only one path, right? Parallel by definition is going to be anything that has more than one path, okay? And sometimes they're a little bit difficult to draw and confusing to look at, but I've already made one for you here. So let me just slide over here. Let me take a look at a typical, right, parallel circuit. Well, what do I mean by more than one path? Well, let's take a look, right? Here's my R total, right? Here's my battery, right? And what's it going to do? It's going to push some current out of the battery, right? So here comes my voltage pushing current I total out of the battery, make its way right up this left-hand side of my circuit, right? And it's going to hop to that point right there. Well, what can this current do here? Well, at this point now, right now, this current has options. Unlike the last time in a series, it was just one path. Now this current gets to here. What can happen? Well, I can get some current go through this resistor 1, and for right now I'm going to call it I1. And what happens when it gets there? Well, I'm going to have some current move up this way. And then what happens when this current gets there? Well, that's the same thing. I can get some current branch off to the right, and I can have some current move up and around the circuit. We'll come back to this in a moment, but here's the difference, right? Series circuit, one path. Parallel, more than one. All right, I also want to take a look just to really understand what's happening. I want to go back to our water analogy, right, which we did last time for my series circuit. And really, this really is the best way to try to understand what's happening. So I'm going to try to make some analogies again between a water pump system and a battery electrical system. So let's recall what a pump does. Well, a pump creates high, right, remember, pressure, and low pressure zones, right? Remember, what is a battery? I wanted you to think of it as electrical pressure. So a water pump really does, in fact, create high water pressure on one side of my pump. And we'll say this left-hand side of the pump is all going to be my, right, my high pressure. And remember what I said last time, my valves in my water system act like my resistors. Remember, the resistors, control or limit the amount of electrical current, right? And my valves here in this system is going to control or limit the amount of water that's going to flow, right? So what's the water? Well, water in my pipes, right? My H2O, that's going to be analogous to my current flowing out of the system. So let's zero in right on this pressure business. Let's say the pump is going to start out pushing at 100 psi. Okay? Right now, I'm going to start with all these valves in the off position closed, right? And this is all full of water. So this pump is pushing on the high side 100 psi. All right, just for argument's sake, what's happening on the low side? Let's make that 0 psi. So if it's full of water, right, wouldn't you see that this pump, side of the pump, the high side, is connected to that side of my valve? Well, if this is 100 psi and it's connected via a pipe, right, I'm going to say that this side right here is also at 100 psi. Well, let's say this side is still connected by the pipes, full of water. What's my pressure here? Lo and behold, it's also 100 psi. And what about up here at this valve up here? Well, guess what? It's also going to be 100 psi. How about this side over here? Well, there's nothing in here. This is 0 connected to the low side, connected to the low side, connected to the low side, connected to the low side. So what do I have? I have all on this low side of my pipe system, also 0 psi. So let's take a look. How can I make this water pump analogous to my electrical circuit? Well, let's take a look. Remember what my battery is. High pressure, low pressure, right? So wouldn't you agree that the high pressure side of my battery is connected via a conductor to the left-hand side of this resistor 1, which I'm going to call 1? Isn't it also connected to the same side of R2? Isn't it also connected to the same side as R3? And what about the low side of my battery? Well, the low side of the battery is connected to the opposite side of each individual resistor. So this leads us to my first relationship for a parallel circuit. And remember, this is going to be my relationship for voltage, okay? Total voltage, which I really mean the battery, right? So what did we say? Well, if this side is the high side, high, 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 and this side's the low side, low, 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 it would make sense that the voltage from the battery is going to be the same as the voltage on R1, the same R2, the same R3. So my relationship in the parallel circuit is V total is going to be equal to V1, it's going to be equal to V2, it's going to be equal to V3, dot, dot, dot. Really what I'm saying is the voltage from the source is equal to the voltage across each other resistor. Now remember, that's a little bit different than the series, but I'll take a look at that in a second. Okay, what about my current? All right, let's take a look at current. Let's just say that I'm telling you, just for argument's sake, you know what, I'm gonna make it red. Suppose this pump puts out 10 gallons of water. There's 10 gallons of water, right? It's coming out of the pump. It meets this little point right here, right? This little node right here. So I have 10 gallons, right? I'm going to abbreviate, coming into this pump. Well, what happens to the 10 gallons? Well, I guess at this point here, some of that 10 gallons can go off to the right. You know what? I'm just going to make up a number. Let's call it 2 gallons. 2 gallons go off to the right. If 10 come in and 2 go out, right? How many have to go up in this direction? Well, this is charge, right? We're really talking about water, but we're really talking about electrical charge analogous. And charge can't be created or destroyed. So if 10 comes in, 10 must go out, 2 went to the right, it looks like 8 must go straight up. Guess what happens here? There's another little spot where I have current, right? Or I should say water at this point, meeting a point where it can branch off. So let's just say I have 8, I don't know, let's say I have 3 gallons move off to the right. If I have 8 coming in, 3 gallons going to the right, how many have to go straight up in the air, or I should say straight to this? Well, looks like it's going to be 5 gallons to me. Okay, so then what happens is, right, I have these water coming out, right? I turn these on a little bit, right? I got some water coming out here, water coming out, right? And how many gallons have to make its way back to the pump? Well, if 10 go out, right, I have to have 10 going in, right? So how many went through this valve here? Well, I have 5 going through here, right? How many went through this guy? 3. So I have 5 coming down, 3 coming over. What happens here? I have 5 and 3. Looks like I have 8. On this one here, I have 2 coming to the right. I have meeting up with 8. How many come down? Well, lo and behold, 8 plus 2 is 10. So how can I make analogies? How can I make an analogy for what happened with the water over here with my electrical system? Well, let's go. Let's just say this was my 10 amps. 10 amps come out of the battery. What happens here? Well, at this point, 10 amps coming up has a choice. It can go to the right and up. So let's use the same exact numbers that I did before. 2 amps moving to the right. That means I have to have how many amps going up? 8. 8 make it to here. Same numbers. 3. If 3 go to the right, what do I have going up? 5. 5 pass through this resistor. 3 pass this resistor. They're going to meet at this node. 5 coming in, 3 coming in. What do I have? 8 coming out, right? 8 meet this guy. 2 meets. What do I have? 10 amps. Lo and behold, 10 amps make it back to my battery. So how can I make a relationship for current? How does current behave? All right, let's talk about the current that comes out of the battery. If I have 10 amps coming out of the battery, right? How many amps have to come back? 10. So what's my relationship here? I total. The total current that comes out of the battery must be equal to the current through resistor 1 plus the current through resistor 2 plus the current through resistor 3 plus dot, dot, dot. Making sense. All right, now, how about resistance? Okay, let's talk about resistance in the series. Resistance in the series, right, the battery saw an overall resistance where we just added all the current together. I'm not going to go through the derivation here. I'm just going to give it to you in English. okay? In this particular system, the resistance is inverse, right, to what happens in the parallel. I'm sorry, in the series. In the series, the resistance just adds. So let's take a look. What happens in a parallel circuit? Okay, parallel circuit, right? The total resistance is the inverse, which really means it goes down. So what that means is I have 1 over R total. It's the inverse, plus 1 over R1, plus 1 over R2, plus 1 over R3, plus dot, dot, dot. So here are my series circuit relationships. This plus Ohm's law, V equals IR, is what we use to solve parallel circuits. Just real quick, here it is on your reference table, right? Everything's right there, right? Nothing that you need to memorize. So there are my parallel circuit relationships, just like I had before, okay? So you know what we're going to do? Let's go through a real quick example, right? And see if we can work through one of these together. So let's take a look. Let's make a parallel circuit. All right, so I have 3 resistors. Let's call the voltage from the battery 24 volts. Let's say that this resistor right here, 1 ohm, resistor 1, 1 ohm. This resistor here, 2 ohms. This resistor here, 3 ohms. Okay? Just like in the series circuit, let's solve for everything. What do I mean by that? Let's solve for the current that comes out of the battery. Let's solve for the current that goes through R1, current through R2, current through R3, and let's find the voltage across everything. Okay? So how are we going to do this? All right, ready? What's the first thing we got to do? All right, just like last time, we are going to make a chart. And as always, my chart is headed VIR. Why VIR? Right? Because this is Ohm's law. Okay? How many, so the columns, Ohm's law, VIR. Rows, how many rows? Always one more row, then resistors, because we want and need the battery. So number 1, make a chart. Number 2, fill in our known values. All right, what do I know? All right, so R1, what do I got? 1 ohm. R2, 2 ohms. R3, 3 ohms. And V total, my voltage from the battery, 24 volts. All right, so there's just about all I can do for right now, right? However, can I use some of my relationships from before? And the answer is yes, I can. Can I find, right, this total resistance? I can. So we are going to find RT. All right, so I'm going to walk you through this equation, okay? First time, right? So 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so here we go. Ready? First thing we do, let's fill in our known values. 1 over 1 ohm plus 1 over 2 ohms plus 1 over 3 ohms. Great. What's next? Convert to a decimal. Well, that's 1, right? 1 divided by 1 is 1. 1 by a half is 0.5. 1 divided by 3, 0.333, right? Then I know this one already, 1.83. So we converted to a decimal, right? Now, so what am I left with? 1 over RT is equal to 1.83. All right, don't be confused here. You're not done. Now we must actually take the reciprocal. Is that okay? Now your calculator has a couple of buttons depending on your calculator. X to the minus 1 or 1 over X. I'm going to show you my calculator right here. 1 X to the minus 1. Okay? So if I did this value, right, it's really the reciprocal, 1 over X to the 1. Try it on your calculator later, right? You're going to get a value of RT is equal to 0.54 ohms. So what does that tell me? I'm going to draw the stuff that we calculated on my chart in red. So my equivalent resistance, right, is 0.54. All right, well, now things are looking a little bit easier for me, right? What can I find next? Well, looks like step 4. What can I do step 4? All right, now I have 2 out of 3, don't I? So it looks like I can do V total is equal to I total over R total. total. So what do I have? 24 volts is equal to what? I total, 0.54 ohms. So we're going to divide by 0.54, divide by 0.54, and I did this already. So you're going to get I total is equal to 44 amps, right? So let's put that in as red, 44 amps. All right, I took the hard way here because I wanted to show you definitely how to do equivalent resistance, right? But let's take a look. What do I know? Well, if we were intuitive in the beginning, right, we know that this is what type of circuit? This is a parallel circuit. If it's parallel, what do I know? Really easily. I know that the voltage across 1, 2, and 3 must be equal to the voltage of the source. So 24 volts, 24 volts, 24 volts. Now life is really easy, right? This is just going to be V equals IR for the remainder, right? So let's see, what do I get? V equals IR, 24 divided by 1, right? What do I have? 24 amps. 24 divided by 12, 12 amps. 24 divided by 3, 8 amps. Lo and behold, we're done. Okay, I'm gonna make another little diagram for you guys, okay? Just like we did before, right? I'm gonna give it to you. Press pause on your little video right here, right? Try it on your own, and I will put the solutions up, right? So here's the ones that I want you to do. So let's say I have R1, 22 ohms, R2, 42 ohms, R3, 7 ohms, right? Voltage, total voltage, 171 volts, okay? So press pause, work through this yourself, right? See how you do, play it again. I'm gonna go through things right now, okay? So here is the solutions. Hopefully you paused, and let's go. Okay, so what do I have? V, I, R, right? 1, 2, 3 total. So what do I got here? 22 ohms, 42 ohms, 22 ohms, 171 volts. All right, we're going to take the easy way here, right? Let's take the easy way now. Why don't we do this guy right here? So 171, 171, 171, right? That's because in a parallel, these are all the same. V equals IR. Like I said, guys, I've had these done already, right? So 171 divided by 22, it's about 24.4 amps, right? This guy turns out to be about 4.1 amps. And this guy here was about 7.7 amps, right? So adding these guys, right, since I'm in a parallel, I total is going to be equal to the addition, right? I'm getting 35.5 amps. Doing a little bit of Ohm's law here, right? I get 4.8 ohms. Right, 24.47, correct. Okay, so that's this one solved. Keep an eye out. I'm going to send you a couple more problems, and we'll go over those tomorrow. All right, be safe.